All right, we're going to take equations and write them in what we call function notation. Okay, and it looks different. It looks kind of goofy because it almost looks like multiplication, but it's just another way to write our y, and I'll show you what I mean. So function notation, if we look at our first little bullet here, it says use parentheses to name the input or the independent variable of the function. Okay, so instead of writing y, we're going to replace it with f of x is what we say. So f of x. And what that means is y is a function of f. Okay, and how this f of x works is that this f just represents the name of the function. So I can name it anything. I can name it f, I can name it g, I can name it h, I can name it all kinds of things. Okay, it doesn't really matter. That's just the letter that represents the function. And what's inside of here says that it's made up of x's. So the expression is going to have x's in it. Okay, there's going to be x's. So let's take a look at an example where this is going to make more sense. So if I had y equals 3x minus 2, and I wanted to write this in function notation, all I do is I replace the y with f of x. So I'm just calling this function f. It's made up of x's, and the expression stays the same, 3x minus 2. And then I might state, well, what if I want to find out what this expression is when x equals 1? What I would do is I would plug 1 into here and figure it out, right? 3 times 1 minus 2 is 1. But how to write it is I'm going to say I want the function of f when x is 1. So I'll take 3 times 1 minus 2. So we'd say the function of 1, the function f of when x is 1 really equals 1. Okay, so this is just a representation of function. It doesn't say f times 1. Okay, I know it's kind of, that's what it usually looks like, but it's saying the function f when x is 1, right? When the x is 1. It's just a way to write it, and so that would equal 1. And you'll see this more when we start going through some examples here. So first of all, what is the domain and range of this function before we look at it more in depth? So the domain, the possible x values, right? Well, my smallest x is at 0, this point right here, and my biggest x is all the way over here at, is that 25 or 26? Well, it looks like these guys are counting by 2's. So that is at 26. So from 0 to 26, so remember we say 0 is less than x, or less than or equal to x, is less than or equal to 26. And how about the range for the y's? What's the smallest y that we have? Well, when y is 0, and when y is 20. So from 0, less than or equal to y, less than or equal to 20. So there's our domain and range. Okay, so I'm going to get values in between there. All right, so I got a function here. And this function we're calling f, so f of x. Right? If we look, our x-axis is called x, and our y-axis, remember we're replacing y with f of x. So if you can see that right up here, we have f of x written instead of y. So that's what that is. We're just replacing y with f of x. So basically this first guy, this f of 3, it's saying, you know, f of x. So when x is 3, what would we get for an output? What would the y be? What would the f of x be? So when x is 3, so we find 3 on the x-axis, and we go straight up, and we notice it's right here, which would be which number? That would be 5. So this would equal 5, which is really the point what? 3, 5. So the x, we inputted 3 right into the function, and we got an output of 5, which is technically, you know, the function of f when x is 3, right? That's kind of what that's saying. So you're really just going wherever you plug in the x and find what the y is. And if I kind of went through and did these quickly, if I look at this one, so first I got to go find, so if I look at the next one, we got to break it up. So first I want to find what f of 5 is. Well, f of 5 is really what? I got to find where 5 is on the x-axis, which is right here. And then I go up, and it's right there on my graph, which is at 3. So that's 3. And we're taking that times f of 4. Well, what is f of 4? I got to go when x is 4, which is right here. Go up right here. So that's also when the y is 4. So this is a 4. So it's really 3 times 4, right? Because f of 5 is 3, and f of 4 is 4. So 3 times 4 gives us 12. So I had to find each of those before I did that. And the same thing would occur in these last two, right? I'd find f of 15 first, and find f of 6, and then divide the 2. Same thing here. I'd find f of 20 and f of 10, and I'd subtract the 2. And I'll just quickly put those answers over to the side for you, so you can check if you want to attempt those on your own. Okay, and then we can get a little bit trickier now. So what about it says x when f of x is 10? X when f of x is 10. So we're trying to find what the x is now. Right, it doesn't give it to us. When f of x is 10. Well, what is f of x really? It's just replacing the y, right? So I want to find when y is 10. So I'm going to go where y is 10. When x would be what? 15. So when the y is 10, or the f of x is 10, the x is 15 now. Okay, so I can do lots of things. So let's look at the next one. Well, I'd find what f of 9 is, and then I'd multiply it by 5. So I don't think we need to look through that one. But what about this next one? This gets tricky. F of 8 times 3. Well, really, I want to find what the f of 24 is. Okay, so let's find that first. The f of 24. So that's when x is 24. I go up, and that would be 16. So I got 16 minus, well, 5 times whatever the f of 11 is. So I got to find when x is 11, which is right here. We go up, that would be 3. And we would subtract. So 16 minus 15 equals 1. Okay, and this last one, just like prior to, it's just like this example right here. Remember, so it's basically saying when y is 0, what would your x be? So I got to when y is 0, which is right here. That would be, x would be 8. Okay, so that one gets a little bit trickier. So that's by using a function when it's on a graph. What if I just have a function as an equation? Well, we can use that to evaluate as well. So now I'm calling my function g. This guy's called g instead of f. All right, and it's made up of x's, and I can see its expression right here, 5x plus 7. So all I'm telling you to do for this first guy is say, take function g, which is right here. Okay, so 5x plus 7. But instead of writing x, I'm going to plug in a 3 for it. So I'm going to plug in a 3 for all the x's. So just like that. So I would say 15 plus 7, which is 22. And to state it, I would say function g when x is 3 equals 22. That's how I want to write that in the end. Because really that's the ordered pair if I were to graph this of 3, 22, right? The x is 3 and the y would be 22 because that's what I'm getting for the output. And what about this other guy? Now it's saying find x when g of x is 57. Well, what is g of x? G of x is this right here, that 5x plus 7. So I'm saying that is 57. Or essentially, I can just replace g of x in this guy up here with 57. So I could replace that g of x piece with 57. So I could say 57 equals fx, or 5 times x, plus 7. And now I'm solving for x instead. So it's just the opposite. So instead of plugging in for x, we're solving for x. So I'd get 50 equals 5x and divide by 5. So x would be 10. So there we go. So basically for g when x is 10, that equals 57. Just like that. Okay, so I could just leave it just as x equals 10, but we wanted to look at it this way to compare it to how it was written before. And let's do this one more time, just get used to it with a little bit trickier numbers. So same thing now, I'm calling the function h. So h, and it's made up of x's, and I'm going to plug in 12 for x. So I'm going to take this 2/3 x minus 3, but instead of x, I'm putting in a 12. And that would give us, well, 12 minus 3 is 9, and 2/3 times 9 is 6. So h, the function h, when x is 12, equals 6. Okay, then it's asking, well, what is x when h of x is 16? Remember, we take that 16 and put it in place of the h of x. So I'm going to say 16 equals 2/3 times x minus 3. Okay, so a couple ways I could do this. I could distribute the 2/3, but since it's being multiplied there, instead of doing that and making extra work, I'm just going to get rid of the 2/3. So I'll divide by 2/3, but we never divide by a fraction, right? We always multiply by its what? Reciprocal. So I'm going to multiply by 3 over 2, multiply by 3 over 2. So that cancels each other. And 3/2 times 16 would be 24, and that's going to equal x minus 3, right? Because this is 24, these canceled, and I still have my x minus 3, so add the 3 over, so x is 27 in that case. Okay, so a little work with your function notation there. Lastly, we could also write an equation in function notation when given 2 points. Well, to write an equation when given 2 points, what do? We always find the slope first. And then remember, we either write it in point slope or slope intercept form. And the only thing to do it in function notation, the only difference is all we're going to do, instead of writing y, we're going to replace it with f of x. So for example, I'm going to write the equation in function notation. Well, first I got to find the slope. So remember, to find slope, we subtract our y's on top. So 11 minus 8. Subtract our x's on bottom, 2 minus 0. And we get 3/2. And I'm going to use point slope form simply because I have a slope and I have a couple points. Okay, and it doesn't matter what point you pick. I'm going to pick this first guy here. So point slope form is y equals slope times x minus x1, so x minus 0, plus the y1. And if I want this in slope intercept form, I could just simplify. I don't have to put it in slope intercept form, but this one wouldn't be too bad, right? Because x minus 0 is actually just x. So I'd have y equals 3/2 x plus 8. But the only thing it says, write in function notation. So what's our last rule? Instead of writing y, we're going to write f of x. So I'm going to replace y with f of x equals 3/2 x plus 8. So there it is in function notation. Okay, and that's really all there is to it.